Hello everyone. In this video, we are going to talk about dependency injection in Angular, what it is, and why do we need it. Before jumping into Angular, let's first understand the idea behind dependency injection, using a very simple and abstract example. I'll assume you already know the basics of the TypeScript and the JavaScript, like classes, interfaces, generics, etc. Now, let's take a look at examples. Let's say we have petrol engine class with a simple start method on it. And also we have this car class that has petrol engine class as a dependency by direct instantiation inside the constructor. At first glance, everything works perfectly. We create a new car, we call in a drive method on it, and we even have this petrol engine started string inside the console. But let's imagine now we want to create an electric car with an electric engine. Can you see the problem now? The car class is tightly coupled to petrol engine. We cannot reuse the car class with another engine type without modifying it. But our goal is to create a car class that can be used in creation of any type of car. So main question here is, what should we do in this situation? And the answer actually comes from the dependency inversion principle, the D in solid. It says high-level modules should not depend on the low-level modules. Both should depend on abstractions. Whoa, sounds kinda complicated, isn't it? So let's break it down. In our example, the high-level module is a car class because it contains business logic, and the low-level module is a petrol engine class because it has implementation details, basically how engine works. And the right diagram shows us current state of things. Car class tightly depends on petrol engine class. Now take a look at the left side diagram. It represents refactoring due to dependency inversion principle. And now both car and petrol engine class depends on abstraction. In our case, this is engine interface with start method on it. Let's move to the refactored code. We created an engine interface and implemented it in both the petrol engine and the electric engine services. We also added constructor initialization for the engine service inside the car class. Now, the car class doesn't care about concrete implementation. It only requires that any engine service implements the engine interface. This is so-called contract. It guarantees that every engine service implements a start method. So to summarize, interfaces define the shape of an object that will be created. In our case, the engine interface would normally have more properties and methods that describe what an engine is, because it forces any implementations to include the core engine characteristics. I'm not focusing here on real engine design, so we only have a single start method, and this is just an abstraction to make the concept easier to understand. Actually, this is because I'm really bad in engine characteristics, but shh, don't tell anyone. Now take a look. Here, I'm passing different engine instances into the car constructor at the creation time. As you can see in the console, both cars are using different types of engines. Actually, by doing this, we achieved a partial implementation of the dependency injection pattern, where dependencies are provided to the business class through its constructor by the third party. And to be honest with you, this is the core idea behind dependency injection. The class doesn't create its dependencies, it receives them. In this case, with our manual help. But now let's make it better. And how can we do it? So, instead of us, we need something that creates dependencies, stores them, injects them, and handles errors for us. That's where an inversion of control containers comes in. What is an IOC container? It's basically a class that handles everything we just talked about, creating, sorting, injecting dependencies, and even handling errors. So we don't need to do it manually now. Okay, now let's move to my implementation. Here I have simplified version of inversion of control container. It has a container property that stores our dependencies. In the constructor, we pass a providers array, which defines which dependencies should be registered in the container. What I do here is iterate over each provider and instantiate it. Each dependency is stored in a map using the class itself as a key. This can work because maps key can be any value, including classes. One small remark, the key can also be called a token. And finally, we have a get method that returns the requested instance by getting it from our map using key. If the dependency doesn't exist in the container, it throws an error. Let's run our app. As you can see in the console, everything is working perfectly. And thanks to dependency injection, our car class is now reusable and easy to configure. For example, we could easily add a tire service with different types of tires, like summer or winter, and even a navigation service without modifying the car class itself. Let's summarize the benefits of using dependency injection. First, improved code maintainability. DI encourages separation of concerns, meaning each class or service focuses on a single responsibility. This leads to cleaner, easier to refactor code and reduces duplications. Next, scalability. Because our services and other classes are reusable and configurable, we can easily use them in multiple parts of the application without rewriting the code. Singleton management is another advantage. BI makes it easy to create singletons, which are objects that are instantiated only once and shared wherever they're needed. For instance, in Angular, we can have state services. They can track the app's state and provide it to multiple components without creating multiple instances. I will explain this concept more further in this video. DI also improves testing. It provides better object isolation, allowing unit tests to use test doubles or mocks as a dependencies instead of the real implementation. For example, you don't have to make real HTTP calls through Angular's HTTP client. You can just mock it. Of course, there are some trade-offs. Projects that use DI can become more complex, and there is a higher entry barrier for developers who are new to the pattern. But overall, the benefits in maintainability, flexibility, and testability make it a powerful tool for building robust Angular and not only Angular applications. So now that we have covered all the basics, or almost all the basics, let's move on to Angular and see how dependency injection works in a real app. Luckily for us, Angular has dependency injection system built in. And I said luckily because sometimes implementing it from the scratch can be such a pain in the ass. And also, it can be configured with providers array. Okay, so how does the Angular team explains a dependency? According to the official documentation, dependency is any object, value, function, or service that the class needs to work, but does not create itself. And the main concept here, as you can know from our previous example, that class will not instantiate its own dependencies. It will get them from IOC container. Yes, in Angular, we also have an IOC containers. They called an injector. The idea is the same as before. It is a class that provides dependencies to other classes. Okay, but you will ask me, how can we interact with Angular dependency injection system? And the answer is pretty easy. Angular has two ways to interact with its DI system. First, you can provide or make available values, and you can inject or ask for values as a dependencies. Okay, let's start by breaking down how providing values works. But first, we need to understand that the modern Angular has two types of injectors: environment injectors and element injectors. In this video, I'm not gonna cover module injectors because modules are kind of an old concept. Nowadays, the Angular team recommends using standalone components and directives. And also because it will make my video 10 minutes longer. Let's take a look at some diagrams. Here you can see that environment injectors include the root environment injector, the platform environment injector, and the null injector, which comes last in the chain. Actually, there is one more environment injector, and this is route injector. We will demonstrate this later in the video. Environment injectors start with the application. For example, the root injector is instantiated during the bootstrap phase and provided dependencies to the whole application. Before that, Angular sets up the platform injector, which handles platform level services. So basically, you can have more than one application bounded to the platform. Think of it like this: you might have a main Angular app and a small widget Angular app running on the same page. They can share services from the platform injector. And in the end of the chain, there is a null injector, which throws an error whenever a dependency can't be found. And maybe you are starting to notice a pattern. Different injectors live at different levels, forming an injector hierarchy. But it will become much clearer when we look at element injectors. Each component and directive get its own element injector. To really see this in action and tie everything together, let's jump into a small Angular app. Our app contains a child component which is used inside the parent components template and a parent component which is part of the root components template. Let's start our application and check it in the browser. As you can see, everything is working fine. We have the root component, which contains the parent component in its template, and the child component nested inside the parent. Now, if you want to follow along, you need to install Angular DevTools. After installing and reloading the browser, navigate to the Angular stub, and then open the Injector tree tab, as you can see on the screen. So here we can see two parts. On the right we have the element injector tree, which contains from child component, parent component, and root component. Left you can see the environment injector tree. It starts with the root injector, then goes up to the platform injector, and finally ends with the null injector at the far left. You might have noticed these arrows between injectors. They represent parent-child relationship. And what that really means is that any dependency provided in a parent injector is automatically available to all of its child injectors. So together, these injectors form what we can call a dependency chain, where Angular walks up the tree until it finds a provider. Now let's take a look at the diagram I created, so we can easily visualize everything we just talked about. Here you can see my representation of the injector tree for our small application. Let's assume we already have a directive inside the child components template. And as you already know, a directive has its own element injector. Now let's assume this directive needs some dependency. Angular will first check the directive's own element injector. If it doesn't find the provider in there, it moves up to the child components injector. Then it goes to the parent component, then the grandparent component, and so on until it reaches the top of the elements injector tree. Then it continues into the environment injectors. First will be the route injector, then the root environment injector and the platform injector. And if the dependency still isn't found, Angular will finally reaches the null injector, which will throw an error. This process of walking from the lowest descendant up to the injector tree has a special name in Angular, and it's called dependency resolution. Now, as I promised earlier in this video, let's take a closer look at the Singleton concept. Let's assume our route injector has instantiated a state service. This service has a field called counter and the method increase count by 1. And as you probably already understood, if an injector further down the chain doesn't have its own instance of the state service provided, it will look up the tree for the first provider it finds. In our case, it will be state service instance provided by route injector. And that means this instance is shared with all of the child injectors. This also means that every injector has its own scope, which consists of all of its child's injectors. And that's why I added these dashed lines on the diagram. They are just here to help visualize the scope of each injector. And yeah, I didn't draw the scope lines for the parent and grandparent injectors because of kind of limited space on this diagram, but basically they have scopes too. This is why if one of the components calls the increase count by one method, it actually updating the same root state object, and the updated value will be available to all descendants of this route. In other words, this service becomes a single source of truth that all these components share. If you are feeling a bit overloaded by this information, go ahead, pause the video, stretch a bit, grab a cup of tea, or no, better will be coffee, and we will pick things up right after. Okay, after a small pause, let's now take a look at the different ways we can configure providers for injectors. And let's start with environment level. So here we have a simple service. It uses the injectable decorator with the providedIn property set to root. As you can tell from the value, this registers the service within the root injector. So let's check it in the DevTools and prove if we are right. We are checking our root injector for the test service dependency. And we have a problem. There is no such provider. Why is that? The actual reason is that providing a service using the providedIn property of the injectable decorator is the tree shakeable. If you don't inject the service anywhere in your code, it won't be registered in the injector. And what's more, the service won't even be included in the final application bundle. And yeah, I didn't inject this service anywhere, so let's do it now. So I've injected the service into child component, and now let's take a look and see if it works. And the moment of truth, indeed, it works. Let's test the same thing, but with platform value. And I think you can guess the result. We now have 9 providers, and one of them is our test service. Another way to configure the root injector is by adding test service directly into the application configuration, like this. This dependency ends up in the root injector because, as I mentioned earlier, this root injector is instantiated during the bootstrap phase of application. And guess where the application configuration is used? Right, inside the bootstrap application function, the very function that starts our app. We also have another way to configure environment injectors, and that is using an injection token factory. We'll dive deeper into that concept later in this video. For now, let's focus on how we will configure our element injectors. And the answer is pretty straightforward. As you might expect, we have a providers array inside the component and directive decorators. And also, we have viewProviders array. They do basically the same job, but viewProviders has an important distinction. We will dive deep into that when we will talk about component level resolution rules. So stay tuned. As you can see, I added the test service to the providers of child directive and also to the providers of child component. Also, I added child directive into child components template. I removed the providedIn property from the service injectable decorator. And for this first check, I will not inject the service at all. So you can see the difference compared to providing it via the injectable decorator. Let's take a look at our diagrams. As you can see, the child directive injector ends up as a child of the child component injector. Sorry for that tautology. And it already have instance of the test service. And the same for the child component. As you can see, it has one provider, and this is our test service. Yeah, this way of providing of dependencies isn't reshakable, and your code always will finish in final bundle. And don't forget that these test services are different instances, one for component and one for directive. Now, when we know this information, let's talk about the different types of dependency providers. Previously, we provided our dependency like this. This is the common way to provide, for example, a service or a class. But actually, under the hood, it looks like this. And what our injector actually does is use the class as a key and just store a new instance of our class created with the help of new keyword. So the value of the provide property becomes the key and useClass is the class that gets instantiated. And that, in fact, is our first type of dependency provider, useClass. So here we're using a class as a key and also a class as a value. So what if I want to provide an object literal or number? Should I create a new class as a key for that? Or use a string as a key? And actually Angular gives us the concept of an injection token. Think of it as of unique key that let us store any value we need and later retrieve that value from the injector. So let's create one. Here I have one. It is created using the injection token class. As you can see, it also has generic typing, which defines the type of the value that will be stored behind this token. The string inside the constructor is just a description of the key, not the key itself. Angular takes care of generating the actual key for us. And of course, don't forget to export it. Now let's implement this emoji interface for our service to define the contract. For simplicity, this interface will just have a single field called emoji. Okay, we'll use our token as the key for the test service inside the provide property of the providers array. As you can see, we now have our injection token as the key in the child components injector, and the provider type is useClass. Next, we inject our token into the component. Here you can see the traditional way of doing this, using the inject decorator inside the constructor. Further in this video, I will show you a newer and more convenient way to handle injection. But for now, let's check the console log to make sure everything is working correctly. And we can see this console log with emoji defined by us, so everything is fine. The injection token class also accepts a second parameter with options object. The first property of this object is providedIn property, which, as we already know, gives us a tree-shakeable way to provide dependencies in the root or platform injectors. The second option is a factory function that returns the actual dependency that should be stored. You might ask, why we need a factory function here? We can use just a class annotation or something like that. The reason is that it allows us to provide different dependencies based on specific conditions at runtime. We will actually see some use cases a bit later in this video, especially since we also have a factory function as a dependency provider for element injectors. Another advantage of using a factory is that it gives us a type-safe way to provide a dependency. TypeScript will throw an error if the factory returns a type that doesn't match the type specified by the injection token. So, as you can see, we can return either a plain object that implements the emoji interface, meaning it has the emoji field, or a service that implements the same interface. But if we change the property name or remove the interface implementation, TypeScript will highlight an error. Okay, let's remove the factory and leave only the token itself, and then check out our next dependency provider. The name of our new provider type is useValue, and as the name suggests, it provides values. anything that exists at runtime. Here I've provided three different values using our token. You might notice an additional property called multi. If multi is set to true, Angular will store all dependencies with the same key in array, so we can access every implementation. If multi isn't used, we will get the latest implementation connected to this token. So in our case, it will be a function that returns emoji with Christmas tree. Let's take a closer look at our dependencies. The first one is a plain object. The second one is a test service class. And the third one is a function that returns a plain object. Now we can check out our console. And as you can see, we have an array with three items. The first one is a plain object. Second is the test service class itself. It hasn't been instantiated by the injector using new keyword. And the third is the function that returns an object. So indeed, we stored every dependency exactly as a value. And if we need to instantiate this class or invoke a function, we need to do it manually inside our component or directive. And I hope you can see an issue here. Our provided values aren't actually the same type as the injection token. Angular allows this, but it means our dependency providers are poorly typed, which could lead to runtime issues. So even though everything compiles, TypeScript can't fully enforce type safety here. So it is your responsibility as a developer to keep everything strict. Constructor injection typing also isn't strict. As you can see in this example, I changed the test service type to a string and nothing breaks. Now it's time to introduce a new way of injecting dependencies in Angular. This is the inject function. That's how new syntaxes looks like. One of the best things about the inject function is that it infers the type automatically. In our case, it will automatically recognize our service as an I emoji type. So now one less thing for us to worry about. And I think I didn't show you. So now let's delete our multi property and let's prove that we will get the last dependency from our providers array. And we are getting function that is last provided dependency. We will talk more about the inject function later in this video. But for now, let's return to our third dependency provider, useFactory. As an injection token factory is just a function that Angular will call every time the injector is created, and it will return the value to be injected. Now, let's check out my example. I created two services, emoji service and a better emoji service. Both are implementing the emoji service interface, but with different emoji values. The first one, emoji service, only has the emoji property, which is set to a smiling face. The second one, better emoji service, also has the emoji property, but it depends on a counter injected via constructor. It sets the emoji field to a snowflake emoji concatenated with the current counter value. I also have a state service provided in the root, which has a counter field and two methods to increment and decrement it. The parent component injects this service and has three buttons in its template: increment, decrement counter, and a toggle button to show or hide the child component. In the child component, we provide emoji service using a factory function. The factory injects the counter from the state service and returns either emoji service or a better emoji service, depending on the counter value. If the counter is less than 2, we provide the default emoji service. If the counter is more, we provide better emoji service. And we render in emoji value in the child component template. At first, we see the default emoji service with the smiling face. But if we increase the counter, let's say up to 5, and then toggle the component's visibility, something interesting happens. And I think you already know that under the hood, the if control flow syntax destroys the previous component instance and creates a new one. But what you probably didn't know is that the injector's life cycle is tied to the component's life cycle. So when a component is destroyed, its injector is destroyed as well. And when a component is created, a new injector is created too. And with the new component creation, our factory is invoked again because we have new injector instance, right? Our factory function has access to the current runtime counter value. So this time it returns the battery emoji service as a dependency. And just to be absolutely clear, the factory has access to the current counter value because a new injector is created at the moment when the counter already has value of 5 in our case. For the last type of the dependency provider useExisting, I've prepared a small example. I added a random number field to our test service. This way, when different instances are created, they each have different value. I provided this service in the root injector and also in the child components providers array. Then I injected test service into both the parent and the child components. As you know, Angular will resolve the root instance for the parent component because nothing is provided there. For the child component, it will create and use a separate instance from the child's injector. Okay, let's check the console logs. As you can see, we have different numbers for the parent and the child test service instances. I've added a useExisting provider. Here I'm using my token as a key, but it doesn't really matter which key you will choose. The important part is that useExisting creates kind of alias for an already existing instance. We are basically telling Angular, don't create a new instance, just look for existing one up the injector chain. In our case, this resolves to the root instance. But if the parent component had its own provider for this service, Angular would use the parent's instance instead, since it's the first one Angular finds in the injector chain, as we already know. And in the console, we see the same number, and that means we are using the same instance of the test service. Now, when we know all the types of providers, let's continue our discussion about the inject function, which I mentioned earlier in this video. We already know that the inject function can infer dependency types, which makes our lives easier when it comes to type safety. The next big advantage is that we can now inject our dependencies into reusable functions, something we couldn't do before inject was introduced. Let's take a look at a small example. Here is my pretty simple example of reusable function. What it does is pretty simple. It injects the snack bar service and displays a message on the screen. In the child component, I added a method called do something and throw an error. Inside this method, I'm just invoking our function. This method is triggered by a button click in the template. Let's look what will happen if we will click on this button. And when we are clicking, we are getting this weird error. Inject function must be called from the injection context, such as a constructor, a factory function, a field initializer, or a function used with runInInjectionContext. So the inject function doesn't just make our lives easier, it comes with a trade-off. We need to understand the injection context concept to use it correctly. As an example, we will take component injection. So, Angular runtime has a context in which it either creates a new injector or uses an existing one. Within the scope of this injector, Angular creates a class with its dependencies resolved. As you may know, classes in JavaScript are just functions under the hood. Let's take an example. Suppose we have a person class with name and age properties initialized directly, and a second name property initialized through the constructor, and also a greet method. Under the hood, it would look something like this. As you can see, during the creation phase, Angular can inject dependencies into the constructor because the constructor is just a function and its parameters can be provided by the injector. It can also participate in field initialization, and both constructor and field initializations is about object configuration. However, methods like greet are just assignments of a function to a prototype property. So function here is just a value that has been assigned to a property. And since function code doesn't run at creation time, Angular cannot inject dependencies into methods because they run later during the already created object's lifecycle. So it will be outside of the Angular injection context. So you can use this kind of reusable functions with inject inside for property initialization. Let's understand how other Angular features like factories, resolvers, and guards get their injection context. We will use a resolver as an example. I created a resolver function that injects a injector and a test service. This service is provided in the routes providers array. Let's check what type of injector we are getting. And as you can see from the scope property, this is the environment injector, and more specifically, the route injector. I need to mention one important thing about the router injector. When you add providers to a route configuration, Angular creates a dedicated injector for that route. The key thing to know is that these injectors are not destroyed when you navigate away. They stay alive for the entire lifetime of the application, which means any service instantiated there also stays alive until the app is destroyed. This works really well for values that are meant to persist across the whole app lifecycle. However, over the time, it can cause the problems, especially with subscriptions that will never be completed, like polling logic. But in many cases, what you actually want is a state service that resets every time you leave the route. Angular addresses this issue starting with Angular 21.1 by introducing a new experimental feature called with experimental auto cleanup injectors. By the time you are watching this video, it might not even be experimental anymore. With this option enabled, after each successful navigation, once router reaches navigation end and becomes stable, Angular automatically cleans up any unused route injectors. So don't forget about it. Next, I'll comment out the route level provider. Since our service has provided in root property, test service is also provided by the root injector. Let's check the console, and we can see different object, the root environment injector. From this, we can see that Angular first finds the injector that can provide the required dependency, and then runs the function within the scope of that injector. Angular also provides a feature that allows us to run any code within the injection context. This is the runInInjectionContext function, which requires two parameters. The first is the injector itself, and the second is the function that Angular will call executing the code we place inside its body. So basically, we can now do the same thing we saw with the resolver. Run our code within the injection context of whichever injector we need. Let's check out the code. So I've wrapped our reusable show error function with the runInInjectionContext function. Here we are using the components injector, and this is the code inside the factory function. Let's check if everything works. When I click the show error button, we can see the snack bar appearing as expected. I also logged the element injector. As you can see, it has a node injector name. Don't be alarmed if it looks different from the environment injectors we logged earlier. This one includes LView and T-node references. Yeah, don't be scared. That's how Angular represents things at a runtime with the help of Angular Ivy. I will show you example with the parents component injector. So this injector also implements the injector interface. So it has the get method. The difference is only in the implementation, specifically how it stores and retrieves data. But we don't really care about the implementation details as long as it does its job. So this is just like I mentioned earlier where we discussed dependency injection at the beginning of this video, right? Okay, now regarding LView. LView stands for logical view. This is how Ivy engine stores the actual runtime data used to render the template for a real component instance, optimized for memory usage and performance. And a T node is the template node, and you need to think about it as a blueprint for a component or directive. As you can see, the T node contains, for example, child information, and it also stores an index that points to where the actual child data is stored in the logical view. Also, you can see that our logical view stores information about our injector factories that also have information about our providers. I won't dive deep into bloom filters, bit vectors, or other internal details of how this works under the hood. If you're really interested, I'll leave some additional resources linked in the video description. Okay, now that we know we can create reusable functions with the Inject API, let's look at one more example. This won't be a real world scenario, but it will help illustrate one important concept. I've added an interval field to our test service, which is provided in the root injector. It is simply an RxJS interval. What I want to do is log the interval values in different components, each with a different multiplier. To do that, I created a reusable function, and it basically just multiplies our interval value by the multiplier. I'm calling this function inside the constructor of a child component. In the parent component, I have a button that toggles the child using if control flow syntax. And it basically will just destroy and create new component for us. Now, as you can see, even after the child component destroyed, the timer keeps ticking. And why is that? Element injectors are tied to the lifecycle of a component or directive, but environment injectors, in our case the root injector, live for the entire lifetime of the application. And you might rightfully say, but you are not even unsubscribing from the observable. And that's actually a fair point. But the question is, how can we even do that? Before Angular 14, cleanup logic was always tied to classes, more specifically to class lifecycle hooks. But now Angular gives us a feature called DestroyRef. It is just a token that provides access to the current injector lifecycle. When the injector is destroyed, it notifies our code about it. It allows us to properly clean up every asynchronous logic, even inside reusable functions. So let's take a look at refactored code. Here I inject DestroyRef and pass it into the take until destroyed operator. This way the subscription is automatically cleaned up based on the lifecycle of the injector, in scope of which this function gets executed. And now our interval stops when component get destroyed. But I'll give you a small spoiler from my future video. This code can be rewritten using signals. And the nice thing about signals is that they automatically handle unsubscription for us. Let's take a look at the source code. As you can see here, the toSignal function prepares a cleanup reference. It either uses an explicitly provided injector or falls back to the default one, which means the injector of the context where toSignal is executed. This is very similar to what we did in our reusable function using inject. It subscribes to the observable and updates the signal whenever a new value arrives. In case of an error or completion, the cleanup logic is triggered. Finally, the important part, if a cleanup reference exists, the subscription is automatically unsubscribed when the current injector context is destroyed. So, once again, the lifecycle of the injector is what drives the cleanup. And as you can see, we achieved same result with our new approach. I also prepared two more real-world examples of utility functions, inject current URL and inject query param functions. You can pause the video and take a closer look at their code, but the important part is that now we eliminated the need to repeat the same logic in every component. We can just simply reuse this function. Isn't that awesome? And of course, you can go further and build more sophisticated utilities. For example, you can enhance inject query param to keep query parameters and a component state signal in sync using two-way binding. This way, the page state becomes shareable via the URL. Okay, let's take a short break. We still have two important concepts left to discuss, so we can put the whole picture together. Now let's understand how local dependency resolution works. By local, I mean within the scope of one or two element injectors. Let's open the Angular documentation so we can visualize an important concept. Every component has a view, which actually is its template, right? Here you can see it represented as a view tag. Also notice that every child element exists within the scope of its parent view. As you might guess, directives don't have their own view because components are essentially directives but with template or view, right? You might also have guessed that a view can have its own providers, and these are called viewProviders. Now let's move on to the code so we can understand this in practice. I added two different emojis to the viewProviders and default providers arrays using useValue, so to make the difference more obvious. I also added a child directive as a host directive. Now let's take a look at which provider gets the result first. And as we can see, in component scope, view providers are first to resolve. Now I'll comment out the view providers line and yeah, we will see what will be next. And we are getting the value from providers array. Now, when I comment out both the view providers and providers array, we can observe a very interesting thing. Our child directive becomes the part of the host. So Angular also checks the directive's own providers array during dependency resolution. Okay, I removed every single provider from the child component as we no longer need them, but instead I added two types of providers to the parent component. And I'm not only adding child component as a part of parent components template, I also using content projection to project one more child component, as you can see on the screen. As we already know, if Angular can't find a dependency, it moves up the injector chain to the parent component. And here's the interesting part. Because the child component is within the scope of the parent component's view, Angular will first check the parent's view provider's implementation. And indeed, we've got exactly what we expected. But hold on, the projected component isn't getting the same value as the one rendered directly in the parent's template. Why is that happening? And one important thing to notice is that children projected using content projection do not have access to their parents' view providers because they are not actually rendered as a direct view children, right? And if you think about it, this makes sense. We even have two separated queries in Angular, one for content children and another one for view children. And as you can see, we are getting runtime error. But if we will put this dependency inside the providers array, and if we will remove view providers from parent, we will get providers implementation. The error is gone and we have same implementation for both our components. Now let's take a look how Angular resolves dependencies for services. Here I'm providing test service in the view providers array. The service injects my token and uses an emoji value. And in the child components template, we are rendering the emoji coming from the test service. And as you probably can guess, we are getting viewProviders implementation. Now I will comment viewProviders implementation of emoji. And after Angular didn't find anything in viewProviders, it will check providers array as it was before, and it will go up injector tree as we saw it previously in a component injection. I just wanted to point out one more important thing. When you provide a service, it only has access to the injector where it's provided, and to injectors higher up in the injector tree. It does not have access to injectors below it or to providers defined at a lower level. As you can see on our screen, the service which is provided in the providers array doesn't know anything about the emoji value coming from viewProviders. So whenever you create a service that has a dependencies, make sure that each dependency is provided at the same injector level or higher. And that's actually all about default resolution behavior. And you will ask, what the heck? Isn't that all? And I will tell you, Angular provides us with 4 resolution modifiers. So yeah, they doing exactly what their name says. They modifying our resolution rules in few different ways. Let's start from the easiest one, and it is actually easy. It is optional resolution modifier. And what it does is simply make your dependency optional. So when Angular tries to resolve the dependency and reach the null injector, it won't throw an error anymore. Instead, it will return null as the value for a dependency. As you can see on the screen, we didn't have any providers for this token, and that caused an error. But after using optional, the error disappears. Just don't forget to use optional chaining operator or proper if checks, because you're still getting a runtime error if you try to access a property or call a method on a null. The second modifier we will talk about is called self. And maybe you can guess what it does. It restricts dependency resolution to the host boundary. In the case of component, Angular will check the view providers first, then the providers, and then the host directives providers, but it won't go any further up injector tree. That's why we are getting error here. But as soon as we uncomment at least the host directive that provides the dependency, everything starts working as expected. So it will not check anything that is above host injector. Next up is SkipSelf. It basically does the opposite of self. It ignores any providers in the host injector and starts looking for the dependency from the injector above in the hierarchy. That's why we are getting parent injector values for both direct and projected child components. The last one modifier is often considered as the trickiest, but not for you guys, not anymore, as you already have good understanding about view and view providers concept. And it called the host resolution modifier. It is actually pretty similar to self, but its boundaries are slightly wider. It can also get the dependency from the parent view. This works the same for both components and directives, as long as they are part of the parent template and not our projected content. Okay, so you can see here that I've commented out all providers of child component. And because of that, if we were using the self resolution modifier, we'd get an error. And I've kept the providers only for parent component. Moreover, I applied host directive. And as you can see in the browser, we are still getting values. And yes, they are different. For the direct template child, we are getting the value from view providers array, while for projected component, we are getting the value from providers array of parents component. Okay, now I'm commenting out the providers array to see what value we will get for projected component. And this is the value from host directive injector. And once we commented out the host directive, we are getting an error, even though there's still another provider for this token at the root level injector. So, with the host resolution modifier, Angular stops at the parent's host element when resolving dependencies for projected content, ignoring view providers. For a direct child, however, Angular stops after checking the parent's viewProviders array. And also we are able to combine our resolution modifiers to achieve, for example, encapsulation. As you can see in my example, I've added 3 resolution modifiers at once: host, SkipSelf, and optional. Because of this, Angular skipped the component's own injector and starts the lookup from parent viewProviders. But because of host, it cannot go any further. And in the case of projected component, Angular won't throw a runtime error even if no providers are defined, because the dependency is marked as optional. Now, let's summarize what we know about dependency resolution in Angular using this diagram. Angular has 2 main groups of injectors: environment injectors and element injectors. Every parent injector provides access to its providers for child injectors, forming a parent-child relationship. Together, they create an injector tree. Dependency resolution always starts at the point where the dependency is injected. Okay, let's assume we have this structure: child directive that is applied to div nested inside another div element that is acting as a host element for the parent directive, and they are part of the child component's template. First, Angular will check whether the directive's own injector provides the requested token. If not, it moves up the injector tree to the parent directive. If the token is still not found, Angular then checks the component's view providers, followed by its providers, and then any host directive's providers. If the dependency is still unresolved, Angular recursively repeats the same process for each parent element injector until it reaches the environment injectors. At that level, Angular checks the route injector, then the root injector, then the platform injector, and finally the null injector, which throws an error if the token is still not found. We can also modify these resolution rules by using different modifiers. Optional to make dependency optional, self and host to define resolution boundaries, and SkipSelf to change the starting point of the lookup. So I think we've covered everything now. To wrap things up, I want to point out that the main goal of this video wasn't to show a bunch of best practice patterns, but rather to help you understand how dependency injection actually works under the hood. Once you understand that, you can confidently open the source code of almost any Angular library and follow what's going on there. And honestly, by reading and understanding source code, you'll naturally discover a lot of best practices along the way. And let me show you one last small example of what we are capable of now. Let's say your application uses mod slide toggle in many different places. You open the Angular materials examples, and it looks like this. But in your case, you want the toggle without the icon. You open the API tab and see that there is a hide icon input. But adding this input everywhere you use the toggle would be inconvenient and lead to a lot of repetition. So it would be much better if you could configure this behavior in one place. And actually, if you scroll down a bit, you'll notice mod slide toggle default options. And yeah, this is InjectionToken. If we open the source code, we can find a configuration object based on the mod slide toggle default options interface. It includes options like disable toggle value, hide icon, disabled interactive, and even color. A bit further down, there is an InjectionToken factory that provides this configuration at the root level. So let's add it to our small app and see if this value will be provided into the root injector. And when we open the injector tree tab, we can see that this token lives inside the root injector. Now, when the mod slide toggle component is created, it walks up the injector tree and finds this configuration object in the root injector. The nice thing is that we can actually override this configuration. And where can we do that? If you were listening carefully, application level config providers can also provide inside root injector, but they override values that are provided using provided in root property. So let's check it out. I'm providing a new configuration object with the hide icon property set to true. And as you can see, the appearance of our toggle has changed. It no longer shows the icon. Let's double check it in the root injector. And yep, there is a new value provided for our token. And this is our application config value. I hope you can see now that the dependency injection is a very powerful tool when it's in the right hands. I want to thanks to everyone who actually survived until the end of this video. I know it was long and maybe a bit boring, but if it was useful for you and maybe you learned some new stuff, I'd really appreciate a like or a comment. I'm already planning my next video, which will be how Angular signals really work. We'll take a look under the hood, how signals work internally, how they improve change detection, application performance, and bundle size. And I'll also go through all the signal features Angular has so far and explain how they work. So, if that sounds interesting to you, let me know in the comments. Alright, this is the end. Peace.